You're all welcome. Over the past 2 years, we've seen lots of advancement in Gen AI. It's crazy. Maybe as I'm speaking now, there's a new model coming out. It's so fast. So we've moved from, yes, this is what the model is doing. And now we want to understand why, it's been a black box. And I'm very happy we have Darya here. And I'm going to just let Darya introduce herself.
Thanks a lot, Cyril. It's always a great pleasure to come back to your stage, to this warm and friendly user group. I really enjoyed it. And keep inviting me for the future. I'm joining from Poland. It's 4 p.m. here. The weather is more or less nice, finally spring. And today we're going to talk about context graphs. So we will talk about today not about, new state-of-the-art model or something like a new technological advantage, but more like the way how we organize our context data. So let's delve in. You will see how, in fact, it is easy to capture context beyond our decisions. And I wanted to start my presentation with a quote from Foundation Capital. It was in December 2025. And they said that the single most valuable asset for companies in the era of AI will be not the models themselves, but the context graph, a $1 trillion decision intelligence layer. And if we think about it, we invest a lot of money in AI, but we rarely give AI one thing, like the reasoning behind our decision and the actual why which runs our companies. So today we are going to talk about, let's take it briefly, what is wrong with AI. And then we will define what is a context graph, how to prototype and do context graph on AWS. We will see a short demo how to actually capture a decision trace. And we will talk about some potential use cases, some thoughts, how to improve. And Q&A, I will try to address questions after my talk. Just if you don't, if you don't want to forget your questions, pass them in the chat. I will go through the chat and, or you can unmute yourself after the talk. I will be happy to answer. So my name is Darya. I'm a senior data scientist at a company called SLB. And I'm also an AWS community builder. It's my 5th year in the program. I like to learn, share my knowledge. Here's my LinkedIn. If you want to connect, I will be happy. And this is my QR code for AWS Builder Center. We can connect there as well. So let's start talking about what is wrong with AI. I know this topic, is crazy. We can talk about it all day long, but let's keep it short. And I wanted to pay your attention on this context gap. Yeah, we have trillions of investments in AI, yet a lot of projects, like 95% of projects have failures. And the reason here is because we are giving our agents data without meaning. And we have a lot of unwritten rules that lives actually in people's head or in some threads or somewhere. People know where they live, but agents don't know where they live. And this actually creates this context gap, the space between what the model can say and what it actually can understand about how your business works. And we can also call it two clocks problem. We've built a $1 trillion infrastructure for the state clock, or what is true right now. We see in our database, for example, this particular customer has a 30,000 credit limit. But what lacks here, we don't know why it became true. Why the limit is 30,000? Maybe it was a manual exemption. Maybe it was like a common rule. We don't know why. And the state clock made sense when humans were this reasoning layer. So the organizational brain could be reconstructed on demand through conversations, chats, questions, and answers. Yeah, and we can compare this to clock problem to a legacy code base. Imagine you see like a old legacy code base, and you see what is true right now. It's like a state clock, but you don't see why such decisions were made, why functions look like this. This knowledge actually lives in some seniors' heads. Maybe they already gone. You don't have them in the company, but you cannot understand why is it so without anyone telling you why. Yeah, and how it actually happens. For example, we have in a company, we have a call and we have a decision during this call, or something is discussed on a Slack thread, and by the time it hits your systems of records, this context why the decision was made is already compressed and faded. If you old old kids game, telephone game, one person pass the phrase to the next person and next and next. And finally, the last person would say completely different thing. Yeah, that was passed by the first person. So this is like a telephone game of an organization. You imagine something in the end and in the beginning, and in the end, it's a complete opposite thing. That's how we play, actually. But a context graph is an evolution that will turn your knowledge graph into decision infrastructure. And it will move your system from mapping reality to governing decisions about it. And also good news that context graph compodes over time. So every automated decision that agent makes, even with a human in the loop, even it's corrected, everything is being recorded, and it creates a virtual flywheel. More captured traces over time, smarter future decisions, and a more safer automation in the future. So let's define what context graph is and what it is not. Let's first start why it wouldn't typical like ordinary RAG work in here. Because typical embeddings, they are semantic, similar meaning, nearby vectors. We need embedding in that case that encode not meaning, but a structure. For example, this concept means similar thing, or that people play similar role, or this situation occurs in similar conditions. So semantic embeddings, they will encode meaning, like lexical meaning, but organizational reasoning requires us to model the structure and the shape of our decisions. A common question here, so context graph, is it a knowledge graph with more metadata? Yes, we can say about it. It's kind of knowledge graph, but it is one on purpose built for AI, because traditional knowledge graph, they were designed for human who were querying and doing the data warehousing, and they lack this why thing. And the difference here would be architecture, because context graph will have 3 specific layers, like ontological grounding. Be sure that your ontology is well defined and cap across the graph. Also, context is compressed. That's why AI retrieval is optimized. And there is one more thing called materialization of agentic behavior. And let's look at it in the next slide. Materialization or reification, that's why we will turn the Y into first-class citizen. How? Because traditionally, if you remember the knowledge graph, a relationship between two nodes is just a line, like an edge between 2 points. But in a context graph, that relationship becomes a node with its own right. And we can attach metadata with information, what happened, who approved this thing, why, what was the condition, what was the exact time, and so on and so forth. So we are keeping a lot of our attention on this decision. And now let's talk about how to do a simple context graph on AWS. To build one on AWS, we can leverage two core pillars, Strengths Agent SDK for orchestration and Amazon Bedrock Agent Core for infrastructure. So Strengths will be like a brain. It will decide which tools to call, in what order. Agent Core runtime will host your agent, while the gateway will give you connectivity to your external systems, memory. And finally, Agent Core memory will handle the context, and the policy will handle who can access what. And it's all interconnected. So this is schematically what we're trying to do. Another question, maybe you heard about Neo4j graph infrastructure, and Neo4j actually has a Neo4j agent memory package, which is integrated with AWS Strengths. But if you're building a true property graph, this thing may be interesting for you. And this is ideal when you have a multi-hop reasoning. For example, customer, account, policy violation, manual override of the policy. So this is for complex things happening. And it uses a poly plus O model, people, organization, location, event, plus object. So it automatically extracts and entities from the conversation and links them together. But we also have like agent core memory, which can like be used as a good first approximation of the hierarchical namespace, which can mimic a graph database, and using which we can log our episodes, our decisions, our traces in a star format for episodic memory. Let's again underline the difference between node embedding and ordinal vector embeddings. So if building graph is more complex, why nodes can be better? In a standard RAG systems, we use tags embedding to find what is textually similar. For example, here we have two very basically identical words, credit and credit, and we can find what is lexically similar, semantically similar. But in context graph, we can use node embeddings like faster P or node to vec to find what is structurally similar. And imagine that this A and B are two different people working in two different departments, but they are actually doing very similar kind of job, but they never interact with each other. So that's how we can find a structural similarity in that context. Why context graph is also interesting, because people like to think in a hypothetical what-if scenarios. And because we captured that event clock, the replayable traces of every decision, we can run such what-if simulations. So for example, if I change my policy today, how would my decisions from the last quarter or last year would look like? And we can ask the system, we can replay it, and the system can log this decision and be like a self-improvement system that will learn both from real data and these synthetic trajectories. And before I go into demo, I need to mention a couple of things. So it make more sense and will be more understandable. So agent core, if you want to go with agent core memory for like a simple first prototype of a context graph, there are actually two types of memories available in agent core: a short-term memory and a long-term memory. So short-term memory is like working memory. It records everything, what the user is saying, what the agent is saying, and it just like unmutable events. But long-term memory allows us to do summarization, allows us to keep the key insights like core information and disregard all noise. So for our case, long-term memory is the ideal choice because we don't need to store, every single word. We just need to capture what is happening in general features, right? And okay, we're taking long-term memory, but there are three built-in strategies: semantic, summary, and user preferences. For our use case, summary strategy would be the best choice because it can summarize in a neat way what was happening and why. And namespace design can be like that. We have some decisions, we have actor ID or like a user ID, and we have a session ID, which is like the session where interaction was. But the namespace design can be flexible. We can think about potential use case, and there would be another namespace design. It's really flexible. And also, I will talk about that later, but agent core memory, what is good, it has also custom memory strategy where you can write your own rules how to store these particular memories. You can override the default prompt, and that can be really tailored to your specific use case or domain. And in order to store these memory records, I created the memory in advance. And it was created beforehand, but really this is something very quick to do. And to make this demo work, we actually need two tools to make it happen. First, we need to store the reasoning, and we have a tool here which is called log decision. And if you see here, we have like a prompt to log the memory in star format. And we use a simple function which creates event and stores it at the moment it happens. So this event clock is preserved. And star pattern, I think it's a quick and elegant way to store the situation from the request due final decision to the final decision. Plus, if we want to store some additional details, we can add additional context. But I think it's really suitable for this situation. And the second tool is precedent search. Every time agents want to help us to make some decision, it is required to go and retrieve memory records. Again, we see here our namespace path parameter, which is adapted to our namespace design. We will be querying decision/user ID. We will be trying to find some past decision regarding this particular customer. And the agent setup is pretty simple, I would say. Yeah, you see the prompt is really not that big. We just ask an agent to, before suggesting anything, go and search for some precedents. And when the recommendation is being made, we need to call log decisions to capture this for future interactions. And I'm using here trans agents, and also for the model I'm using, I think, Claude Sonnet 4.5, but it is really flexible because because if you're using some like advanced model, it's not a big difference between them in that case. So this is the repo link. If in case if you want to try it yourself, you don't want to start from scratch, I will also pass this link to the chat. And there's a QR code with the same link. And let me just bring my PyCharm here to show you the demo itself. So first, it's a little bit messy here, but we will do like this. So first, let's try to see what we have for a particular customer. Let's call this function. We're not interacting with the agent itself. We're just doing lookup what we have for the Tim Chan. So Tim Chan was our customer, and we have a simple query that they are trying to request a credit increase here. And if we do the precedent search, just print here. Yeah, we see just one record in our database, and it is being printed here. Somewhere in April last year, they requested this increase. And actually, that was kind of suspicious because there were multiple transactions over like half an hour, and it was flagged as a high risk. And there were some further actions after that. So we know that we already have something in our memory. We have something to reason about, and the main demo is here. So let's assume I'm an assistant, and now Tim Chan is calling or chatting with me, and they request like 35,000 credit increase. Yeah, and I don't know, maybe I'm a new hire, a new staff, and I don't know the history, but I need to take that decision. And if I run this, and if I ask an agent for help, agent will first do the precedent lookup, as we did, and they will see what we saw, that there was an incident last year. And before they suggest anything, agent will log decision and create a new memory event in our database, in our agent core memory. And here is a recommendation. Based on the precedent, it should be rejected because there were some issues in the past, and we don't have the right to approve it without any senior management review. There are some reasoning, next steps, and a summary. Okay. So, but you can, of course, you can play with different customers. You can play with different fraud patterns, different decisions. And by the way, what we queried today, that will be stored for the future as another request. So it will become an addition, a new trace to our context graph. Yeah, the demo was quite simple, but there are a lot of like ideas how to take it further. We can search for common patterns across different users. Maybe we have, some common fraud patterns, and we need to be prepared for this. Also, as I already said, if we're not quite happy with this summary memory strategy, we can use a custom memory strategy, and we can store it in a way we would like to see it. And also, if you want to deep dive and go into like fully graph, embedding fully graph database, you can use Neo4j graph embeddings like FasterP, but take a note that they're available on Neo4j Graph Data Science, which is available in Neo4j already as on Neo4j Enterprise Edition, which, you need to think about your budget, and you need to think about whether it is appropriate for your use case. And I also wanted to, because you saw an example in finance and banking industry, but I also wanted to show different use cases and examples where it also can be interesting. AWS has interesting site reliability engineer agent with an example in an official repo. And there was like one scenario, for example, a Kubernetes pod can fail, and you can see from the log that this pod is failed, but you don't know why. A context graph can help you and tell why was it this issue. So you can log it in a star memory format. Yeah. And when the agent is recorded that, like next time, you can see the similar incident and you can see, okay, this looks like a memory leakage, which caused out of memory kill. So you can actually record all your incidents, and next time debugging and searching for a reason, potential reason for the incidents can become more and more simple, because you will have like a full history of precedents. And if we talk about different industries, think about companies or industries where we have exception-heavy decisions, where people often say it depends, or organizations that exist an intersection of systems. For example, DevOps, it exists because someone has to bridge development, IT, and support. And there are like many such complex domains where storing context and querying the context may be really, really helpful. For example, imagine healthcare. We have a lot of, let's say, cases, and we need to bridge these cases with research papers, with similar incidents, which something that was happening in the past. Same for supply chain. If we want to track like a lost package, we don't know why it happens, but there are a lot of similar incidents, similar precedents, and we can store and query that knowledge. And a customer support, we can also use this history track of historical records to improve our customer support. And finally, legally compliance. I think this is maybe the example number one, because we have laws, but we also have different precedents, and they are so important for this particular case, because they can alter or they can, tweakle the law in a significant way. Okay, so let's talk about pros and cons of context graph. First of all, we have a reduction in hallucination compared to standard track, and compared, of course, to the situation where the agent has nothing to query. And because every decision becomes an audible causal chain, you can see the path the agent took from a policy to a precedent to query what was happening. And also, it is token efficient because your context is being compressed and stored in a smart way, rather than agent would need to go and find a lot of documents, a lot of policies, and you don't know whether it will find everything that is required. But there is no free lunch, of course. In order to have this context graph, you need active metadata, like a live stream of events from your existing systems. Otherwise, how would you build it? Also, let's say that you need to think about implementation. If you're going with graphs like Neo4j, you can face infrastructure overhead and implementation complexity. And also you need to think carefully about how to model what is important in your decision. How would you design like a graph or namespaces? You need to think about it upfront. Okay, and that leads us to key takeaways. We spent decades on building systems of records, what is true right now. But the next opportunity is to capture the reasoning behind our work. And on AWS, you already have building blocks already today, strengths for the brain and agent core for the memory. So my suggestion is to start small, pick a decision, have a workflow where it depends would be like very common answer, build the graph, capture traces, and then let your context compound.
I have a question. You mentioned a very, very nice presentation. I really loved it. I will give it a try. But then my question will be, at work we are trying to implement a graph rack solution for this QC agent, quality control agent, that actually responds or evaluate the transcript for another agent, conversational agent. Do you think this use case could be, we can use instead of a graph rack solution, we can use a context graph solution, and then how will this affect the latency of the solution?
Okay, but let me ask you a question. What is the primary reason you want to have graph rack for this agent?
So we try to implement a graph rack solution in Neo4j because we want to store the previous evaluation of the transcript from conversation between AI agent with the customer. So we build this to extract entities and then build this knowledge, previous information about the evaluation of the transcript. But then we have a lot of problem with the embedding, vector embedding, the re-ranking step in the graph rack. So that's why I was thinking that it could be possible that we can use the context graph instead of a graph rack solution.
I would say if you need from the agent, if you need and you expect some reasoning why is this done, why it is not done, I think you can give it a try with a context graph. I don't think the latency would be big in that case. One reason why you shouldn't do context graph, potential reason, if you're building a context, if you're building the knowledge graph because of the, you need to link ontologies together, you have some complex ontology in your system, and you just really need to build this, knowledge graph to capture the ontology, and that's it. You don't need the why reasoning in here.
Got it. Okay. Yeah, I understand. And what about the latency? Do you think the latency will be better by get rid of all of this complexity of the graph rack, the re-ranking step, the embedding, the construction of the embedding models, vector, will be better to use a context graph?
I think if you will try to do with something like I did, like agent core memory, I don't think the memory or the latency would be that big. I think it will be even smaller than with knowledge graph.
Okay, thank you for your answer.
You're welcome.
I was just curious about the recent announcement that we were talking about in the chat there, Cyril. If Darya, if you looked at that, about how AWS just announced OpenSearch serverless that scales to 0 now, if it means that using something like OpenSearch makes more sense now. Before it was super expensive if you were just doing something small, but now it's a little bit cheaper. And I was mentioning about Neo4j. We used it before, but we actually got rid of it just because of the pricing model. I'm not sure if you've looked at other solutions other than Neo4j, and if the pricing the quality of what it gives you justifies what they charge for it, basically.
My subjective take here is if you have money, if it is not your concern, I would try to do it with Neo4j because they are really investing a lot in the graph and new features, and it just an interesting, you're paying them, but in return you have a lot of features coming like every month. Yeah, maybe it is worth trying. Yeah, about OpenSearch serverless. Yeah, that was the reason I kind of looked away from it in the beginning. I didn't heard about this announcement. Yeah, I need to see whether the pricing, like how much it was adjusted. Yeah.
Sounds like you're saying that Neo4j is really a leader in this space and they offer the best features. So even though they do cost money, if you want to try out the newest and greatest and something that's specialized in this area, give it a try, is basically what you're saying.
Yeah, but the question is whether your workflow needs that. Yeah, whether you want to, just go there. Let me just try from the other side. Yeah, if you want to start small, yeah, you can start with Agent Core. You can play with trends. Yeah, but if you're ready to dive in, if you're ready to invest from the beginning, you can start from Neo4j and just stay on it.
We are very grateful that Darya, you were here to come talk with us, to come share this knowledge with us, and we expect that we can go try this out, customize them to our specific workloads. So thanks everyone for attending. Yeah. Okay, thanks.
Thank you.
Thank you very much, everybody.
Bye.
Have a nice day. Bye.